Okay. So we have a construct point. I'm gonna just make a real quick way of setting up a row of points on both sides. I'm just gonna set up one on the y-axis and one on the x-axis. I'm gonna shift them from the 0. You alright? Yeah? Yeah, I'm recording. I'm recording somebody dying. You okay?
Oh, yeah.
Yeah.
Swallowed the wrong way.
Okay. So, the example we were just talking about, right? This is what we had. Is a list of points over here. And a list of points over here. Right? This is what we were just looking at on the board. And then we have a starting point and end point. So, what's happening right now, right? We have branch 0 up here, branch 0 here, and then index is 0 through 9, and index is 0 through 9. And so this line here that's happening, this first one is connecting point 0 to point 0 to then create line 0, right? Then point 1, and both branch 0 and branch 0 create line 1, right? Very easy. Okay, so now I'm going to right click on this output and I'm going to graft, right? So now we see we have multiple branches here and all the points are indexed 0. So if I only had one point here, right? Oh, let me move it so you see what's happening. Right, like this point connects to point 0, right? And so that creates line 0. Now, all the other data items here, they're also being put through the command, right? So they need some other equivalent data to connect to. So because this is the only one on the other side, it's stacking. This one's connecting to every other result, right? If I had 2 points, right, it's the same thing that we brought up earlier. Well, it's grafted. If I ungraft, right, we have 2 points. So we see here, 0 is connecting to 0 this way. 1 is connecting to 1. But then all the other ones, 2, 3, 4, 5, all the way to 9, they're stacking onto the last item in the list, right? Which is point 1 over here. So when I graphed here, that's why it's going to everything, because this is like its own list. And so it doesn't have any more items, so then after 0 has connected with 0, 1 then stacks onto 0, and 2 and 3 and 4 and so on. And that happens for every single branch, right? So here, all of these points are connecting to all the points over there. But if I graft on this side, right, we go back to the same structure, where it's linking branch 0 to branch 0, 1 to 1. There's no leftover, so there's no stacking, right? So why is this useful, right? Well, let's say for example I had, like we just had those lines. I'll bring back the line. So here I'm gonna keep it just so that they connect to each other, right? But now let's say that I wanted each one of these to connect to a system that's above, right? So I'll just draw out a line above. And do set one line. We went over this, right? How these link over to Rhino. Let me actually do it side view. Okay. So now let's say I wanted to loft, right? So if I wanted to loft this with those, right? what's happening here is, actually I'll do a merge. So instead of putting in 2 wires into one input here, I'll use a merge component to make them into the same list and then plug that through. Okay. So you see there that it's grafted, right? And we can see how that's happening. So the merge component is taking this line that I drew in Rhino and it's keeping it in its own branch. And then it's keeping the list over here of lines separate in its other branch as well. That's why when we're seeing it through the loft, we only see it happen through the bottom and not to the top one, because the top one's on its own. It doesn't have any other curves to loft with, right? So that's why here I'd have to flatten in order to include that into the operation. Yeah? Alternatively, right, if I wanted each one of these lines to link to this line, what should I do?
Wait, can you ask that again?
If I wanted each one of these lines on the ground to loft to this curve floating up here so that they're each its own surface, kind of like a fan, how would I do that? By flattening or grafting right here.
You not just said that each point is towards, I guess, like triangulated to the right, and from each point?
No, well, there's,
Yeah, you told me the edges.
I'm asking like flattening or grafting one of these outputs or inputs.
Flatten the second output, right?
What is the second output?
The bottom one.
Line?
Yeah.
You said flatten, but it's actually grafting.
Oh,
So if I grafted here, what I'd have to do is I'd have to make sure that this line is now going to merge in each one of these branches, right? So I'd also have to graft here, or not. I'm gonna work around, instead of having a, sorry, I thought that would work by grafting there, but the merge isn't quite bringing in that line into each one of the branches. It's simply adding it to the wire continuous thing, but it's not including it into a branch, it's kind of keeping it in its own branch. So at that point, we can look at something else I plan to get to a little bit later, but we can start looking at that now, which is how do you modify lists by index, right? So if you go to your sets tab, under list, here you have a lot of ways that you can edit your lists, in sequence as well, but it's a little bit different. But here I have one that's called insert items, right? So I'm gonna bring that one in instead of the merge. So how does this one work, right? Well, we're inserting some item into a list of items, right? Right now my lines are on their own, right? So each line has an index of 0, and they're just in different branches. So if I plug in this list of lines in here into list, I'm not plugging in, don't think about it as like plugging in a bunch of lines, right? Think about, or one list of lines, think about it as plugging in lines that are in their independent lists, right? Because they're all indexed 0. Now the item that I want to insert into each one of these branches is this line, right? For the loft. So I'd bring that as the item that's being inserted. Now, what index do you think I should place here for this line to be introduced appropriately to each one of these branches?
The action?
So the index is this number that identifies the objects in a list, right? So it's asking me now, what index should I give the item that's being plugged into the lists, right? So that it's plugged in at the proper order.
Do you just connect the panels with it?
I'm asking for the index input here. What am I to plug in there? It could be 0.
Numbers.
Could be a number slider, but it has it to be a number. It could be 0, or it could be,
Zero wouldn't give us what you're trying to do, right?
huh?
0 wouldn't give us what you're trying to do.
In a way. The thing is, this is the index at which it's going to introduce this line into the lists, right? So since these lines already have index 0, I'd have to continue from that, right? So if I plug in 1, I would see that that line up here is now inserted into this list at index 1, right? Had I put 0, it changes the order. It's replacing the one that was originally 0 and pushing that down to 1. Do we get this? Yeah? Okay. So with that, it's lofting to, right? Because each branch has now 2 curves, and every branch has this curve in it. Right? So that becomes useful when in robotic control, like let's say you have a robot picking something up here, like you have a list of commands, right? So that list of commands is go here, turn on, or go here, move up, go here, move down, right? And then you need to introduce, activate the gripper and deactivate the gripper, right? So if you have, right, 1, 2, 3, 4 commands, you're activating the gripper at 0, and then you're deactivating it at
3.
I have 4 commands, right? 1, 2, 3, 4. I'm introducing a command in the beginning to grab, right?
So that would move it forward. So you have 6 and then you have 7.
Well, it'd be at 6, but with index being 0, it'd be 5, right?
Yeah.
So turn on, or move to position, right? Turn on. I guess you would then introduce it at 1, not at 0, right? So if you have your list of movement here, right? 0, 1, 2, 3, right? So you're introducing at 1 so that it moves, turns on, 2, 3, 4, and then 5 is shutting off, right? So besides this, there's also another way to preview how your branches are working. So it's called the param viewer. So if you're keeping pretty good track and you don't need the panels to really know what's going on, the param viewer component, let me drop in bifocals. The param viewer component is going to, if you plug it in, it's going to let you know how many branches and how many data items in that branch, right? So here I have 1 branch with 10 items, right? Here I have 10 branches with 1 item each, right? I can right click it and I can ask to draw a tree. So this way it's going to show me how the data is flowing, right? Again, this is just one list, right? Branch 0. And then here I have the 10 branches, right? And it's kind of letting you know they originate from a command where they came together, right? And then at this command, it's splitting, and it's splitting into all these different branches, right? So if I were to then graft here again, it would show further divisions.
So this does not really affect the model, it just shows you what you are trying to do.
It does affect the model when the organization of these items in the list is relevant to the command. Like in the loft, right? Because here I'm grafting everything now. So it shows here that it was split twice, right? It was split once here, and then it was split again here. So then the end result is that they're each in their own branch, and so loft can't happen because no curves are sort of in the same list, right? If I don't graft here and I keep it how it was before, it's only split once, but we have 2 lines in every branch. If I don't graft at all the lines are in one branch and it's sweeping through all of them.
So basically graph separates all the points?
Exactly. There's, where is it? Sets. So under sets, under the set category, you have this over here called tree. And under tree, you have a lot more options for how you can organize these things. So for example, flip matrix. I've had to use this before, but I'm not sure if it's relevant to this case right now. But let's say, for example, explode tree, right? Like if I have all these, oop, not there. So So if I have all these surfaces, right, and I want all the surfaces, but I want to isolate something to surface 7, right, and do something with surface 7. So explode tree will allow me to plug it in there. Now remember, orange or yellow means an error that it's missing data, right? But it only has one input, right? So I can hover over and it says tree contains more branches than this component has output parameters, right? So it's supposed to link a branch to every output, but it's saying there's not enough output parameters. So there's some components that you can add outputs or inputs if you zoom in close enough. So here I just have to add outputs until the amount of branches in the list matches the amount of outputs. Now I can isolate any one branch, right? Meaning this one, for example, right? Now, let's say I want to do something to this. Let me grab the last one so it's visible. Yeah, the one on the top. I'm going to just use a plugin real quick called Lunchbox just to do some panels. I'll do some hexagonal panels. Now, if I take a look at the list of these cells, right? All these panels, right, on that surface are in one list, right? If I wanted to isolate one of these, right, they're not really in branches, right? So I can't explode tree and isolate that branch. So I could instead identify the object by its index number, right? So again, where sets are, under your list components, right, to separate your list, you have here list item. Retrieve a specific item from a list. So I can add that in here. And again, we would identify by index. So if we have up to 60 lines or 60 cells, I can type in a number slider, say at 55, cap it at 60. And then with the index, I can go through each cell, right, by the number that identifies it.
So what was 55?
I just typed in 55 to get something from 0 to 100.
Okay.
But then I edited the number slider to cap at 60. So what happens when it's not capped, right? Because I capped it at 60 because the last index in the list was 60. So if I go to 61, right? It starts over. It just wraps around. So 61 is the same as 0.
Okay.
Instead of grafting, right, where you're splitting every item into its own branch, you can also partition the list, right? So if I have 60 cells here, I can bring in this list. I can say I wanted the list size to be limited to 10. So then I get the list, right, broken off into sets of 10. I have one left over, so you know you want to make sure that that makes sense, however you set it up. I guess 9 gives no leftover. Yeah. Reverse list is simple. I mean, if you wanted to, if we go back to the initial example with the line, right? They're all connecting this way. If I use reverse for one of these, it's obviously just going to reverse the order in which they connect, right? I can also reverse by right-clicking just like I do flatten and graft, right? So I don't necessarily need that component. I mean, graft and flattening are also their own components here. For whatever reason, like you wanted to put through a component rather than do the right-click. I'm trying to think what else I can go to. Sublist, sort list, shift list. So let's say I want to keep building on this, I guess, to show you like I guess how it can continue. Shift list. Okay, so let's say these cells, right? I did something weird. One sec. I'm gonna undo the reverse. Yeah. So these cells here, right? Let's say I wanted them all to extrude a different amount. right? So we'll get rid of partitioning because it doesn't matter. Well, no, I don't need to partition. Actually, let's use the partitioning to our advantage. So I have 6 branches, right? The last number identifies the branch. Like all the other numbers, it relates to sort of what it's remembering, right? That it came from. So if I look at the param viewer and I draw the tree, right? It relates to how it's been split, right? So here it was 0, 0, and then at one point, remember, we grafted into 9 branches over here, right? So that's the 9 over here, and then 0, and then 0, and then the last number is identifying that branch within this particular moment, right? So branch 3, branch 2. So all these numbers are really just references of how it's gone down before, but it really doesn't help you in any way. And you can even right click here and hit simplify and just get rid of that data. Just keep it with branches. So again, I have 7 branches, right? 0 to 6. And let's say I want each branch to extrude a different amount, right? So I can use something simple like a series, right? I can start the series at, say, 2, increase by 3. So I'm going to ask for 7 because I have the 7 branches, right? And so with extrude, I put in these, right? The cells in this part after partitioning the list in this amount of curves. The direction I set to Z. Right, now when I plug this in, right, so each list is receiving a different amount of extrusion. Right, and we can take a look at that here. It's not there, but here. Or is it overlapping? So let's say right now I wanted to check and see if item 0 went to branch 0 and item 1 went to item 1, right? Simple mathematics. If I have 7 branches and I have 7 numbers, right? I should still have 7 branches with it, with 8 items in it, right? So if I had too many, like if say I was getting 0 to whatever on every single one, like if I were grafted over here. Oh. Oh, okay. So what's actually happening is, it's not what I expected, but yeah. So here's the curves that are being extruded, and here's the values for extrusion, right? So it's connecting 0 to 0, right? So this one is extruding 2. This one's extruding 5. This one's extruding 8, right? 11, 14, 17. And then because there's 2 more items, the last 2 are also extruding 20, right? And then the same case for all the other branches, right? But when I graph down here, what's happening now is this whole branch is extruding 2. This whole branch is extruding 5. Right? This whole branch is extruding 8, and so on. Yeah?
Can you control how much it extrudes up to?
Yeah, so that's set up here in the series. So rather than doing top down, where I say from here to here this many, I'm actually saying start at 2, increase by 3 so many times. So this has to remain, well, this one I guess, until I match. That's the thing, like here they're overlapping because it's not matching the number of indexes. But then when I graph this, it's not overlapping because it matches the number of branches.
Could you just change the values in the 2, 3 through 7 is what you do on the bottom left?
Oh, here?
Yeah.
Yeah, so if I change, so to match the lists, you mean? The indexes?
No, if you can just change the numbers, like, so I understand how.
Oh, how it's behaving? Yeah. So this is the starting value. So it's the minimum value that's being applied for extrusion, right? And then this is the increment in extrusion.
Okay.
So then this is the amount of values for extrusion. So here it matches the branches, but then when it's not grafted, it's overlapping. So then I'd have to increase the count until I have the same amount of items over here as I do over here in each list, if you didn't want it to overlap. Okay. Any questions so far? Besides those? No?
How would you give extrusion height to each and every extrusion?
For each one?
Yeah.
So in that case, it wouldn't be partitioned, right? Because if they're all going to be different, I need to treat them in one list, right?
Okay.
So that each one has a unique index, right, at that instance. So if I'm just bringing the hexagonal cells for extrusion, I get rid of partitioning, right? So right now, again,
It's all equal.
let me. So, right, I have 8 values for extrusion. So then at number 9, 10 is simply stacking on everything below that. That's right. That's why we see the first row be lower,
Yeah.
right? And everything else in the back has the value of 10. So if I wanted each one to have a unique value, what I would simply do is I'd do list length. Right, this is the easy way. Because series is asking for count, right? So if I ask for 9, it's going to give me 9. So if I say this list has 61 items, it'll give me 61 values. So there they each have one value. There's another way to do this, which I'll introduce. Well, I've talked about attractor points before now, and I showed you guys that.
You mentioned it.
I mentioned it, I didn't go into it?
Yeah.
No? Okay. So we'll do that now. So another way to derive a unique value for each one of them is to calculate their center points to something else, right? In whatever way. So let's say I have a circle that goes around the geometry. I'm going to do curve. Right? And then I'll use point on curve. Point on curve is simply going to give me a point on that curve. This is the start of the curve, this is the end of the curve, and then I get everything in between. If I right click on it, I can snap to a quarter of the way, midpoint, so on. Okay, so now we'll do distance, right? We'll just calculate the distance from that point to the center points of all the hexagonal cells. Right, so then here I have distances, but if I plug in these values for extrusion in the z direction, right, it might be a little, actually it's not bad, because it's directly related to the point, right? The distance that it has to the point is how much it's extruding. So as the point moves, the extrusions change, right? Now, to modify this, because let's say I wanted to extrude, I don't want it to extrude that distance, right? I want it to be informed by the point, but I want it to extrude a maximum of 20, right? And a minimum of 5. So I think we talked about this a little bit before too. It's basically stretching or contracting the domain of numbers, right? What's called here remapping. So when you remap, you have a list of values, right, that you're constricting or expanding, but you want to keep their relation to each other, right? Meaning that if my domain is from 0 to 10, right, and I have numbers 2 and 4, right? If I switch the domain to 0 to 5, 2 and 4 would become 1 and 2, right? It's simply like dividing by 2. It's halved, yeah. So the values here, right, are the ones that are going to be remapped. Source, domain, right, for the values that are being plugged in. I could, what I used to do was use sort list so that all the numbers would get in order, right? So I look at the smallest value and then at the largest value, and I construct a domain with those numbers. But actually there's a bounds component that you can plug in a list of numbers, and then it'll give you the domain, 9.23 to 20.4, right? So that's my source domain. Now I can construct my target domain, which I said could be, 5 to 20, right? So now what was 9.23 is now 5, and what was 20.41 is now 20. Right? I guess I'll make it lower just to make it a little bit more noticeable. If you're using a cool way to animate this, right? If you were to have something like this that you wanted to show for class, you can do a custom preview. Right? Add the extrusion there to the preview. The default material is always pink. You can add a color, RGB, or whatever other way of picking a color you want. And then it's RGB, so it goes from 255 to 0. So 255 would be maximum red. And then if I have rendered view, I can see the Grasshopper geometry rendered. Without baking it, right. It's the custom preview component is having it rendered over there. So now as I move the attractor point, if I want to see the attractor point, there's plugins to make these values change and export frames as they're changing. But when I'm feeling lazy, like I don't want to script anymore and I just want to get this animation done, I'll just do a record of the window, and then I'll go real slow as I'm changing it, and then I'll speed it up in After Effects or Premiere or whatever and make it smooth. But yeah. So this is why did I do 3? Yeah, this is why understanding data lists is important, because once you get to complex operations, especially where you're having data inform the geometries, you're really going to have to understand how these items are connecting to each other, right, or how they're relating, because you might think, oh, I need to keep working till I get it to do what I want it to do, and maybe it's just a quick restructuring of how the lists are organized. All right, that was pretty heavy, no? Yeah. I tried to take my time with it though and just focus on that. So hopefully, again, it's recorded so you can listen to it again. It's not the first time I bring this up. I've brought it up in the past. I've just avoided explaining it until we can kind of sit down and do it. So this is going to come up a lot more next week when we do KUKA PRC. We'll start implementing this into sending instructions to the robot. And so it'll become very important to know where you should introduce instructions of shutting on, turning on, activating, deactivating, as well as why do you want to do this movement a point to point versus a linear movement versus a spline movement, and how can they switch from one to the other, right? Okay, so any more questions? No? All right, so we'll end it there so you can comfortably get to studio. And thank you guys for sticking around. We'll do this every Tuesday and Friday at noon. And if I don't see you the rest of the week, I'll see you guys next class.
When did you say the CNC training is?
I think we're doing it every day except Wednesdays and Saturdays.
Okay.
But the schedule is posted up around the studio and on the door of the shop. And you can go ask at the shop for them to sign you up for training. Let your classmates know too in studio.
Do the hours for the regular, the table saw one, does that carry over from last semester?
Yeah, so if you did a woodworking training last semester and you have 2 left
I
to
have one left.
Yeah, you can do that now, and then yeah, it's 3 like forever. You do 3 woodworking trainings, and you're okay to use the table saw.